Good morning, everybody. Pathetic. I got up, you got up, try again. Good morning, everyone. Aha, now I know you're there. All right, welcome to Microsoft Ignite. I'd like one more cheer quickly. Indicative of volume. How good is the show so far? I'll take that, I'll take that. My name is Dean Wells. I'm a program manager in the Windows Server team. And in this session, our goal is to kind of convey how we think about security and how we thought about building the solutions that we built into Windows Server 2016. Now, I know you've seen an awful lot on security, and I will say at this point, blatantly to everybody who plagiarized my slides, please let me go first next time. So what you see here that looks like a duplicate was mine first. It's so unfair. Nevertheless, so what I want to do is give you a little bit of context about the way we think about engineering these features in Win Server 2016, as well as in Windows 10. Now, we know about the cybercrime, this cost estimate. You've seen this slide a few times. These numbers are daunting, to say the least. Absolutely massive numbers, even by Microsoft's standards. Now, what about some of the hidden costs, though? None of you have seen this slide before because I got wind of people plagiarizing slides, so I deleted these and added them back at the last minute. Clever, huh? That way I get some uniqueness. Take a look at this up here. We've got a before situation where customers pay you for your service. What do you think happens after a publicized breach where it's documented in magazines? You end up paying compensation to keep that customer. So money's going out the door rather than in the door. Employees efficiently working with IT systems that allow you to do whatever your job is. What happens after the fact? After the fact, clever, huh? If you've got a fax machine still, they're now doing business based upon paper, sending fax messages all over the place, assuming you've still got a fax machine. What about this, where you over-exaggerate the result? Some breach comes in, it's publicized, and then, of course, you have this knee-jerk reaction, and you overspend on the IT to go ahead and rectify whatever the root cause was. Worse, if it's unidentified, you'll over-exaggerate it even further. What about this, though? Gets even worse from here. Credibility. Many of you have heard about all of the large retail companies that have been attacked. The breaches were public. You know for yourself, your own reasons. Did you lose some faith in them? Certainly for me, I lost some credibility with that organization. I, at the very least, went and changed my password to something pathetic and never used the account again, erased any sense of credit cards that they may have stored there. You lose credibility by virtue of these breaches, especially when publicized. HBI and MBI assets, ransomware. This is something I've got a personal association with. My wife's small company, very tiny, only 30 employees or so. What do you think they do for IT? They have some dude called James that knows a little bit about Windows who built an Active Directory domain controller, and that's the extent of their IT. They hit ransomware. One of their file servers, pretty much their only file server, was infested, and it encrypted the vast majority of their documents. They were going to pay. She called me and said, what should we do? I said, why don't you restore it from backup? She said, OK, I'll go ask him. So that wasn't even the first call, because the ransomware apparently said, your backups are also encrypted. This is ridiculous. These guys are able to attack small companies because they don't have the IT expertise. Eventually, they restored back 5 days. Sure enough, ransomware gone, at least for 4 hours, because they forgot to repave the machines that had the ransomware. The same attack worked twice. It's very, very easy for these kind of guys to attack these kind of companies. We've got to stop this stuff from happening. Obviously, we can't stop all of it, but we can do a great deal in the technology, but we can also do a great deal with how we operationalize IT. Last but not least, customers happy to trust you with their PII. That is not going to be the case afterwards. Customers will be happy to charge you with lawsuits or anything else they care to, but they're not going to trust you with their PII any further. Now, let's talk about the type of attacks. The stuff on the left is what we've been dealing with for years. This is the stuff that every Tom, Dick, and Harry company out there deals with. We've got anti-malware, we've got antivirus, we've got firewalls. We've got deep packet inspection firewalls that actually look at the messages. We've got firewalls that encrypt, or rather intercept SSL connections to ensure that the bad traffic isn't hiding inside an SSL tunnel. All of these things have been going on for years. The stuff on the right is rather unique, though. What about the virtualization fabric attacking that? That's one of the core elements that you're going to see throughout Ignite from a security standpoint. We realized through extensive research from our Trustworthy Computing group and from Microsoft Research itself that the virtualization fabric is becoming one of the prime attack vectors because workloads today don't run on bare metal anymore. Very few workloads run on bare metal. Those that do are typically virtualization fabric machines themselves. There's the attack vector. or super sensitive workloads, such as Active Directory domain controllers. People don't necessarily like to virtualize those because of the security loss. Now, I don't know if any of you know what I mean by the loss of security. The loss of security I'm referring to is, say, a TPM. TPMs are fantastic devices that allow you to seal encryption keys so that encrypted disks will only be decrypted if measurements pan out to be accurate. Does anyone know what I mean by measurements? Give me a quick show of hands if you know what I mean by TPM measurements. I think I can see. OK, I would say that was about 4 from what I could see there. So what I'm talking about is BitLocker uses a technology from UEFI called Secure Measured Boot. And what it does is it takes measurements as a Windows machine boots, and then it seals a key to those measurements. The TPM will only release that key if the measurements are the same when it's asked to release the key. The measurements are measuring every single action that constituted the boot of that machine. So it measures the firmware, it measures the bootloader, it measures the kernel, it measures the drivers, and if anything changed in a way that it doesn't like, it will refuse to release the key. We can't do any of that really clever stuff that we can do with bare metal, where we deploy domain controllers and we encrypt their file system. We can't do that with virtual machines because they lack these kind of security devices. That's the attack vector that we're talking about. Now let's talk about the timeline for a second. I know you've all seen this slide before, so I changed it a bit yesterday to make it look different, but it's effectively the same one that you've seen. We have no idea how long the research and prep phase takes, but we do know that it only takes from 24 to 48 hours before a domain admin credential is stolen. That's not a good thing. It's not a good thing at all, and we've been working very, very hard to ensure that that's no longer possible. I assume most of you, again, by volume. How many of you have heard of Credential Guard? No, I said by volume. That was hands. Anyone speak English? OK, try that again. By volume. I can't see you. By volume. Who's heard of Credential Guard? OK, it wasn't as loud as the how much do you like the show, so clearly not all of you. Either that or you're less enthusiastic. Credential Guard is a new technology in both Windows 10 Client and Server 2016 that has the ability to prevent administrative processes, even things running with full admin privilege, from reaching in to a component in Windows called the Local Security Authority and stealing credential artifacts so that it can replay them later. Sure, we can detect that stuff, but it's even better if we simply protect it through isolation. That's what Credential Guard does, and it uses the very same technology that we've been using to protect Virtual Machine 1 from Virtual Machine 2 when running on Hyper-V or VMware or Citrix. It doesn't matter. All the hypervisor vendors use the same platform technologies to put those defenses in place between two virtual machines. We're now building that into the OS, regardless of whether it's running as a hypervisor. We leverage the virtualization capabilities for security purposes. We refer to that as virtualization-based security. And it's rife throughout Windows 10 and Windows Server 2016. It's also, as far as I know, one of a kind in the market. So here's what happens. The attacker sits there, they're undetected. Data exfiltration occurs. Maybe you detect them at some point, but can you honestly say that you've detected every lingering remnant of that software? It's a very, very difficult thing to do. So our first call of action has to be do our very best to make sure that it doesn't get in, and if it does get in, do our very best to isolate the things that would be secrets that allow it to further the attack, or increase the chances of gaining access to yet more data. So that begs the question then, what do these attacks have in common, if anything at all? They do have something in common, and it took us a long time to figure out what that was. It's obvious in hindsight. None of these attacks are worth a salt if they don't get an administrative privilege. None of them are worth anything. Pass the hash. You can pass the hash of a guest user. What good's that? Your goal is to get a privilege that gives you access to the keys to get to the asset you're trying to steal. Now, the problem is, we designed these systems to work this way donkey's years ago. How many of you can go back to Windows NT 4? I can just about see. A lot of you. How many of you can go back to Windows NT Advanced Server 3.1? You're old. How many of you can go back to LAN Manager? NetWare 2? OS 2? Gem? Really? OK, you're as old as me. Holy crap. All right, so these products were built with this convention in mind donkey's years back. We designed it to have a notion of an administrative privilege. Think about the administrative privilege of DOS 6 with Windows 3 on top of it. The administrative privilege was turning it on. It didn't have users, so it didn't really matter. Then when Windows NT Advanced Server came out, oh yeah, now we're getting there, but the admin was there from day one. NetWare with a supervisor user, LAN manager, 3+ open, 3+ share, Unix, Linux, it doesn't matter. Every single incarnation has this notion of an admin priv. So we briefly considered removing the notion, the very concept of an administrator privilege. And what do you think our customers said when we vetted that against them? Don't be an idiot was the basic concession. So we didn't do that in the end. So let's go back. This is what I was referring to. When the first personal computer was designed, sure, we gave it admin privs. Didn't matter. Breach one, breach only one. Then virtualization came in. It wasn't normal yet. We used to call them virtual machines. The term fabric hadn't been invented. But the problem there was, if you got the admin creds to the hypervisor, you had access to the virtual machines running on it. And the problem got much, much worse when private clouds started to become the norm, when every workload, bar a few, were being deployed as virtual machines, and then the public cloud comes in and arguably makes it even more disconcerting because now it's tenant boundaries, or it's hoster to tenant boundaries that are being torn down by gaining these admin concepts. We have some documentation. Take a quick look at what you see on screen here. We've put a great deal of effort into producing this. This is available already, aka.ms/privsec. There are 3 tiers of actionable things written down for you that you can do to ensure the security of your current infrastructure. The first one is completely free. We only give you links to things that you can download and policies that you could implement. The second one, I believe there's a slight cost for the 1 to 3 months, but it's not major. But the third one is where it really comes a little bit painful from the dollar standpoint. You're going to have to get your wallet out for that one. But I encourage you to go take a look at that. There's a lot of effort that came into this from a lot of people in Microsoft with some very big brains, far bigger than mine. So there's some good stuff in there to take a look at. So the lessons that we got out of this are what? Well, here they are. First, the network is no longer the security perimeter. I would argue it hasn't been for a long time. Again, by show of hands, I'll try and look. How many people agree with that statement? The network is no longer the security perimeter. Okay, good. That's a good number of you. More of you should. The reason being, identity is the way in which we keep intruders out today. Most companies, most large enterprises no longer require that you VPN in to gain access to corporate web services. I can gain access to Microsoft's human resources data about me from my house without a VPN. What is the security perimeter of that website? My identity. Do you think I'm allowed to use just my username and password? Hell no, is the answer to that. No, I'm MFA'd. Using Azure MFA, my phone tells me you've got to do a biometric swipe to authenticate. Makes it just as difficult to get in as a firewall, arguably. So it's no longer the case. We can't just rely on network perimeter security to keep the bad guys out. Entry, we're not going to stop this from happening. People will be fooled. The larger your organization gets, the more likely it is that one of those individuals will get some malware or be bribed or coerced. Further down the list, eliminating human error. That simply isn't possible again. We're human, we make mistakes. Insider attacks, we know this is a big deal. One of the best things to prevent insider attacks that we learned is use collusion. Make an insider be forced to have to collude with somebody else to gain access to the asset, because now all of a sudden they've got to take a risk. It doesn't trap them all because there may be 3 individuals, so the collusion's not going to help there. But if it's just one malicious dude, collusion is a fantastic barrier. Compliance is important. The point I want to make here is, yes, attain compliance, but do not stop there thinking that compliance equals security. A compliance bar today will state that the disk is encrypted, the files are encrypted at rest. Well, an encryption technology is only as good as 1, the cipher, and 2, the way in which the keys are released. What if the keys are stored on a floppy disk that's left in the machine? Then the encryption technology is stupid, it's pointless. We need to have secure key release technologies. It is fundamental. Encryption by itself is not enough. Strong ciphers with strong key release policies. It's mandatory. And lastly but not least, prevention methods aren't always technical. Some of these are going to be architectural or operational. You're going to have to pay an operational price if you wish to increase the security. It's the usual tug of war. Convenience on one side, security on the other. So here's the Windows Server security posture. If you like, 4 tenets that basically govern how we think about building security into the platform. The first is we've got to continue protecting it. We have to continue to work as hard as we can. We can't just sit back on our laurels and go, protection doesn't matter anymore. That would not make sense. So protection is one of the first and foremost considerations when building anything new. Detection. We have to do well with detecting when these things are breached. That's the only way in which our response technologies can be leveraged. And we've got a whole slew of technologies specifically tasked at detecting attackers. So obviously we've discussed response there, and then isolation. We're building isolation in all over the place. Credential Guard, Device Guard, virtual machines with shielding capabilities. They all build on isolation technologies, every single one of them. So there are three buckets that sort of come out of these four core tenets. One, we have to manage privileged identities. Two, we have to secure the OS, whether it's a host or a guest. And three, we have to secure the virtualization platform. So let's start with managing privileged identities. We've got just-in-time. Again, by a quick roar, because I can't really hear you, who knows what just-in-time administration is? Oh, that's pretty good. I'm just going to make up a number. That was 56%. Good job. The remaining 44%, talk to the guy next to you that knew what it was. Just-in-time admin is a way of ensuring that you don't log on with a privilege that you do not wield. Log on with a privilege that you need for whatever you're doing here and now. If you need to do something administrative, go through a just-in-time system, which is the bottom one in that list, I believe. Note the third one. Managed elevation, a privileged account management, or a privileged access management, or a PIM, a privileged identity management. They all mean the same thing. Make sure you've got systems in place to keep people with lowly privileges until such time as they need them. When they do need them, ensure that they expire after a credible amount of time, 30 minutes, an hour, whatever needs be. And then I mentioned earlier we've got Credential Guard. We also have a sister feature called Remote Credential Guard, which is there to protect remote desktop connections alongside CredGuard. And then right down the bottom, we've got bound credentials. Would anybody like to take a guess at what I mean by bound credentials? You can yell it out if you do. Anyone know? I'm going to go, that's no then. So bound credentials are a way of sealing a set of credentials to a device, and that is the only place where they have meaning. Bound credentials, an example would be, let's say, a virtual smart card. Why is a virtual smart card a bound credential? Well, a virtual smart card uses TPM functionality to simulate the same capability as a smart card does. But you can't take a VTPM off of a motherboard. If you do, you don't have a motherboard anymore. You have a piece of circuitry in two halves. It doesn't work. That's one bound credential. Windows Hello, that capability where we give you special passkey phrases, or where we're using biometric scans of your face. That's all bound credentials. It will work only on that one device. Somebody steals that credential artifact, it is useless unless they got your device too. That's some good stuff. That's very, very helpful. What about securing the OS? Device Guard, code integrity. This is code integrity like never before. We've had kernel mode and user mode code integrity in Windows for a long, long time. Device Guard in Windows 10 and Server 2016 uses hypervisor-enforced code integrity. We're using the same virtualization-based security technologies that, again, we use in Hyper-V, that, again, we use with shielded VMs, that, again, we use with Credential Guard, to ensure that the policy itself can't be tampered with. And get this, if an admin tampers with a Device Guard code integrity policy, it can be configured to be locked. If it is locked, that means we secure a computed footprint within the UEFI firmware, such that when the machine reboots, if the computed footprint and the current code integrity policy do not match, the machine will say, it is better that I die now than allow the data to be stolen due to the absence of a blessed, legitimate code integrity policy. What do you think Windows does when it likes to die? What does Windows do when it likes to die? What color would that be? Blue, there you go. We blue screen. This is by design. You don't have to lock it, but it is by design. If that machine being in a non-operational state is a preferable outcome to having the data stolen from it, then you can lock a Device Guard policy to the UEFI firmware. The only way of breaking that is physical access to the machine, which you secure physically with padlocks and cages and security guards, and clearing the UEFI firmware, the variables specifically. So that's some really clever stuff there. If you take a look at the host and guest integrity, you can see I've put lines there indicating these are parallels. And the host, we've got a hardware-based root of trust. We base our trust, we anchor it in TPM technology, TPM v2 or TPM v1.2, depending on what we're talking about. We use UEFI secure measured boot. We seal keys to TPMs and boot measurements. In the case of a virtual machine, we use a synthetic TPM, and we also use VSM-based trust. VSM is virtual secure mode, or phrased another way, VBS, virtualization-based security. The same thing over and over again. You can see the pattern repeating. This is the basis of a lot of our security technologies. We are hinging it in platform capabilities that were originally designed to allow one machine to run as two, and then it can run four. Virtualization. That's what they were designed for. But they also secure virtual machines from one another, so they have no way of communicating unless they're allowed to. We're using those same technologies and plumbing them into the OS as a way of making the security stronger. Finally, secure virtualization. This is where we have things like shielded virtual machines. I'll give you a brief demo of those in a second. How many of you have already seen a demo of shielded virtual machines? That wasn't many. OK, I'll do the demo. We also have Hyper-V containers. How many of you have seen a session on Hyper-V containers? That was more. That's unsettling. I own shielded virtual machines, not containers, so that was a little unsettling. How many of you think virtual machines seriously rock by round of applause? OK. How many of you think shielding is a natural extension of virtualization? Yes, that's what I like to see. Good for you. All right, and of course, we've got software-defined networking with microsegmentation capability. Greg will be up here later giving you a demo on how that works. So with all that, what is one thing that spans all of it? Monitoring and detection. That last tenet that I haven't really talked about. We have to ensure that we can monitor and detect when breaches occur. So that spans every single technology that I've just mentioned. In whatever manner it comes out, various things such as more fine-grained event logging, things such as OMS, to go ahead and correlate event logs into something useful and provide you with operational intelligence so you can do something actionable. So that's all the theory that I wanted to do for now. What I wanted to do was sort of hand it over to products that Microsoft have today, both in the cloud and on-prem, that embrace these principles. Now, the first one, as I said, is shielded virtual machines. So you can see there I've got a session coming up on this later. So let me go ahead and switch over to this box here. All right. This, then, is my data center in a laptop. I've been carrying around a hulking great ThinkPad W520, and if any of you have ever picked one of those up, you know why my back hurts. But it is a data center in a laptop, so it's going to do everything for us here. So what I'm going to do first of all is I'm going to go and attack a non-shielded virtual machine. So let me show you this briefly. What I've done is I've opened up a SAN, that device there, and I'm a SAN administrator with some malicious intent. Let's assume that I'm possibly colluding with the Hyper-V admin, because that would give me leaps and bounds yet more access. So I'm a SAN administrator colluding with a Hyper-V admin, and the first thing is I need to get some passwords out of Active Directory. I go into the virtual disks. I go into the VMDKs, because it's a hybrid platform, and I will use the joke that Jeff used, since he stole it from me. Can they shield? I don't know what a VMDK is, to be honest. It's not an area in which I have any expertise at all. But can you shield that disk? I'm not sure you can. Can you encrypt that disk? Maybe you can. Can you encrypt that disk on a platform that runs with attestation and ensures that the host is healthy? Can you encrypt that disk on a platform that's running a VM that has a hypervisor-enforced code integrity policy? I don't believe all of that's possible with that particular file format, but I'll show you one that it is possible with, and we'll start with one that isn't shielded. This one here is a regular virtual machine. It is not protected. I double-clicked on it, the double-click attack, to borrow Jeff Woolsey's terminology. I literally double-clicked on a VHDX. How can I do that? How can I just double-click on a VHDX? Because Windows fully supports VHDXs. They are useful file system constructs. We use them even outside of virtualization. We use them as boot disks now. We use them to contain an entire OS and boot environment, so it's portable as a single file. It's super convenient. So Windows lets you mount it. I double-click on NTDS, right-click on the DIT, copy it, go back up to the top, go to my USB drive, and paste. I take the USB home with me. I insert it into a computer at home, copy off the DIT, download one of 4 or 5 tools that are on the internet now that use brute force techniques to try and crack passwords that are stored inside that database. One of Active Directory's major capabilities is backward compatibility. You can still domain join Windows NT4 if you permit it to do so. But to do so, it has to maintain hashes that are arguably too old to be maintained today. But companies can't get rid of this stuff. So these technologies that are out there that you can download from the internet start targeting those legacy hashes until they find a plain text string that matches when hashed. Ultimately, they end up with a key value pair stored in some kind of password file that looks roughly like this. My password is not Mary Poppins with dollars, for those of you that were tweeting about it. I didn't actually put my own password up there. It could be Mary Poppins, but it isn't. This is what comes out. So if I was colluding with that Hyper-V admin, what can I do now? Well, at this particular point, I can do pretty much anything I want. I could go into the Hyper-V manager. I could double-click on a machine, such as this SQL machine here. When that connection comes up, I'll get a credential provider. I'll type in the credentials that I just stole out of Active Directory. I'll log onto the machine, and I'm effectively a SQL admin at that point, or a domain admin logging onto that SQL machine. So that's what a little bit of collusion will do with a Fabric administrator. So let's go ahead and show you how I can stop that from happening by quickly deploying a new shielded VM. So this is a user interface here that is very simple. It is arguably simpler than deploying a regular virtual machine. So my goal here is deploy a brand new shielded virtual machine that the attack I just demonstrated could not possibly succeed against. Standalone, from gallery. I'd like to use medium for shielded. You can see the icon here, the top icon that's a cube. That's a regular template. This is just regular Azure Pack user experience. The icon beneath it, the shield. This implies that this will deploy a shielded virtual machine that is born secure. Our developers spent weeks in Paintbrush there with 1-bit color and the pencil to draw that one. It took ages. It does distinguish, though, right? I'll click on Next, at which point I give it a name, ADDC3 or 2, whatever I'm typing is fine, and I select the shielding data. Of course, you're now going to ask, what is shielding data? This is the piece that you own. You, as the virtual machine owner, would run a tool on premises, a nice graphical wizard called the Shielding Data File Wizard. It is an encrypted lump of secrets that you put into there. So it spews out a PDK file that is encrypted using tenant-owned keys. It contains things like the administrator password, so that you don't have to type the administrator password in when deploying a new VM that you want to protect from a Fabric attack, because if you type the password into a web form owned by the very admin you're trying to protect the VM from, well, I think there's a 5-letter word that starts with ID that might well describe you. But none of that's you, of course, because I wouldn't ever refer to my audience in that way. But you wouldn't want to deploy a shielded virtual machine and give the guy the password when doing so. So the password is embedded in shielding data, along with an RDP certificate to mutually authenticate any remote desktop connections, and something called a volume signature catalog that is there to insist that the integrity of the template disk from which the shielded VM is born be measured and recomputed from a known, trusted, healthy point in the past and compared now. Are they the same? If they're the same, the template disk has not been tampered with. So that's that attack vector precluded. We then click on Next, and of course, we connect it to a network, and we're done. Now, it would take that about 5 to 7 minutes to deploy. So here's one that I created earlier, ADDC2. ADDC2 is a shielded VM running Windows Server 2012 R2, and it's running Active Directory as a domain controller. You can see down the bottom, I didn't get a thumbnail for it. No thumbnail. That's because it's shielded. If I double-click on it and I try to console connect, it won't permit it. Not merely because there's an if condition that says, if vm.type equals shielded, don't do that. No, it can't do it because it runs as a protected process. Specifically, it's a type of process that Windows understands called a protected process lite that refuses to allow other processes to attach to it. So we can't attach to that VMWP, the worker process. We're not allowed to do that. You can't attach a debugger to it. For that matter, its disk is encrypted. The key is sealed to a VTPM. The host on which it runs has to be measured, and attestably so, as healthy by a service referred to as the host guardian service. The definition of healthy is decided by you as the person that runs the Fabric or runs the host guardian service. All of these technologies constitute what we refer to as a shielded VM. OK, so what I'd like to do now, then, is I think it's a good time for me to hand it over and let, who's coming up first? It's Michael, yes. Michael, why don't you come up and give us a demo of ATA, and he's going to walk you through a few attack vectors that ATA can spot very, very early on. So quick round of applause for Michael.
Thank you. Thanks, Dean. So first of all, I'll have to speak a little bit slower than Dean. I'm not British, and English is not my native language, so apologies for the speed differences. Nice to meet you. I'm Michael Dubinsky. I lead the product management team for Advanced Threat Analytics. And with that, we're going to start with talking a little bit in more details about the advanced attacker skill chain. So Dean mentioned that in the advanced attacks, the first part of actually getting to the domain admin creds takes a matter of a couple of hours or a couple of days. So let's take a quick look about what happens before that. So basically we start with the external reconnaissance phase, or the attacker starts with the external reconnaissance phase. We don't really know how long it takes. And then they manage to get access inside the corporate network. Now, by managing to get access inside the corporate network, it could be either because the attacker managed to compromise some external-facing assets, maybe the VPN servers, proxy servers, whatever I have out there on the web. Maybe it's some of my cloud devices or cloud VMs. Or they managed to compromise one of the endpoints by malware, by phishing, or whatever other method. Now, once they've done that, think about it. The attacker landed in a completely new area they know nothing about. They know nothing about the IP addresses that are being used in the environment, what OSs, is the environment running Windows devices, Mac devices, Linux devices, is the environment using Active Directory? All that kind of information is something the attackers are collecting in order to figure out their initial attack vector and how do they get to the domain admin creds. Now, once they've done that, they managed to get a non-privileged account, either because they landed on a device with that account available to them, or they managed to sniff the network with some other information. And they begin the low-privilege lateral movement cycle, where their goal is to get to the domain admin creds. Now, once they got to the domain admin creds, to the privileged account, their goal is to gain persistence in the environment, to gain domain dominance. Now, the reason for that being, we don't want, as the attackers, or the attackers don't want to be dependent on a single set of credentials. They spent months preparing for the attack. They spent a lot of money preparing for the attack. Now, if I only have, my entire campaign is dependent on that single username and password, what happens if the password gets changed? That's it. My campaign is over. So that's why the attackers are looking for persistence specifically by the domain dominance. Now, when I say domain dominance, the double-click demo, or the double-click attack that Dean mentioned previously, stealing the NTDS DID file, is domain persistence. Basically, I'm taking the entire database. I have all the usernames, I have all the passwords, I have all the hashes. I can come back to the environment whenever I want because the chances are within the next 6 months or the next year, not all the user accounts are going to change their password. Now, there is one small other problem. Do not require user to change password. Do you know the checkbox in Active Directory? Or password never expires? That's the second biggest problem, right? So I know that even in years, some of the passwords will not get changed. So now that we've done that, the next part is the high privilege lateral movement cycle. So I have the privileged account. My next goal is to figure out the asset that I want to access. So it could be if I'm attacking a financial institution, it could be the database holding the credit cards. If I'm attacking a pharmaceutical company, it could be the formula that I can sell for a lot of money, the intellectual property of the company, whatever the case is. Once the attacker managed to get to that point, their goal eventually is to exfiltrate that information. So specifically for credit card, the attacker's goal would be to get all the credit card information to themselves so they can sell it on the dark web. Now, each credit card costs between $5 US to $15 US, depending on the quality. But eventually, if you steal thousands of credit cards, the attackers are pretty rich only based on that attack. So that's how the attacker kill chain looks like. Now, how ATA helps? Well, ATA helps by combining two types of detections: behavior analytics and deterministic detection. So behavior analytics is basically building a statistical model based on how the entities in the environment behave. The users, the computers, the resources, everything. So we learn how users behave, for example, by learning which devices are they working from, which resources do they access, what are the normal working hours, and then we feed all that into a machine learning algorithm so we can detect anomalies. So for example, a lateral movement would look like a single user account logging in from a lot of devices they've never used before. So that's one method of detecting lateral movement cycle. The second thing, the deterministic detection, is basically looking at the techniques the attackers are using and detecting that specific technique or the essence of that specific attack. So if we're thinking about pass the ticket attack, for an example, what does the pass the ticket attack mean? That means that we're taking the attacker is taking a Kerberos ticket that was issued to device A and using the same Kerberos ticket from a different device to which the domain controller has never issued that specific Kerberos ticket. Now, with ATA, basically what we're doing is we're building a relationship between the Kerberos ticket, the users, the devices. And now when we're seeing that the Kerberos ticket is being used out of context, basically from a device that it wasn't issued to, we're flagging that as a pass the ticket attack. So that's a deterministic way for detecting a technique. Now, it doesn't matter if you're executing pass the ticket attack using Mimikatz or MIT Kerberos or any other method, the technique is still the same. So that's a deterministic way of detecting suspicious activities or attacks. So that's what ATA brings to the table, and that's basically the advanced threat detection we're providing. If we're looking at the attack kill chain, where ATA is, basically in the big part in the middle, from the internal reconnaissance phase until the asset access. The lateral movement cycle, the compromised credentials, all those capabilities are available with ATA. So now, let's see a quick demo. Of how ATA actually detects suspicious activities. So in my environment, I have a couple of VMs. First, let me open those. So my first VM is the VM where the attacker have landed. Now my first goal, as I mentioned, would be to run the reconnaissance attack. So in this example, what I'm going to do is I'm actually going to run a guessing of the username. So the attacker landed in the environment. They have absolutely zero knowledge what kind of usernames exist in the environment. So I want to try and guess. So what I'm doing, I'm using a tool called KerbGuess, and I have a dictionary of usernames. Now this dictionary is pretty small. It only has 60-something usernames. But basically, the attackers are coming in with thousands of usernames, and they're trying to guess those usernames by trying to authenticate, but only one specific part of the authentication. They're not finishing the authentication process, so it's neither a successful authentication nor a failed authentication in terms of guessing. So let's run that. I have actually a batch file that runs the KerbGuess with the IP address of the domain controller and the dictionary file. Now, we got the results back. We got the results back that we've managed to detect, to figure out the ATA SVC account and that specific user account. Now, looking back at the ATA console, we can already see that we've detected the reconnaissance attack using account enumeration, and we're providing all the usernames that were attempted in the dictionary, including the guessed usernames. So now we know which usernames exist in the environment. My next attack would be to try and steal a Kerberos ticket from an administrative device and use it on the device the attacker have landed. So in order to do that, I'm going to log into my administrative device. It's coming, it's coming. Here it is. I'm going to log into my administrative device, and I'm going to use Mimikatz in order to steal the Kerberos ticket. So, wrong folder. Here we go. That's Mimikatz. So obviously, as the attacker, I would probably do those things remotely. But here, just for the sake of the demo, I'm going to dump all the Kerberos tickets locally. So let's run Mimikatz. Use the right privilege. And export all the Kerberos tickets that I have on that specific machine to files. Now, that's something that Credential Guard that Dean mentioned earlier would prevent me from doing. I won't be able to dump most of those tickets into files, so as the attacker, I won't be able to steal those tickets and use them, which I'm planning on doing right now. So in this example, what I want to take, I actually want to take the TGT of NAC Choris, our privileged account. Now, just for the sake of copy-paste, I do need an enhanced session. I'm going to copy it back to the victim device. And again, using Mimikatz, I'm going to import that into my logon session, which then I'll be able to use in order to access the domain controller with a privileged account.
Can you zoom it, Michael?
Yep. So I managed to successfully import the Kerberos ticket for NAC Chorus. I can actually see that I have that specific Kerberos ticket. And now I'm going to try and dir into the C dollar drive on the domain controller. That was pretty successful. So now I've escalated my privileges from a standard user account to a domain admin user account. Now, using that specific attack vector, now I'm a domain admin, and I can do a whole lot of things against the domain controller. I can steal the database. I have access to the C dollar drive. I can dump all the tickets. I can do a lot of interesting stuff specifically against the domain controller. Now, with ATA, in a couple of seconds, that specific suspicious activity would show up, and we would see that ATA detected a pass the ticket suspicious activity. In the meantime, here it comes. I trust the product I own, you see, very optimistic. So that's pass the ticket attack, and obviously there are a lot of other attacks that ATA can detect, and I'll be more than happy to see you today at my session at 4 p.m. about ATA, or on Thursday about how to properly deploy ATA in your environment. Thank you very much.
Great, thank you very much. So as we said then, and I think Michael pointed it out as well, that attack is not particularly simple, but Mimikatz has effectively menuized a way in which a previously extremely technical attack, a very complex, very sophisticated attack was conducted. It's turned it into something where you type in a few commands from a menu that actually has help built in. So it's a little bit scary to consider how easy that is to do. It makes you feel a lot better that ATA can detect it quite literally in seconds, as Michael demonstrated. And you'll get alerts, and obviously you've then got some remediation to do. The first thing you would probably want to do is at least disable that stolen account. Credential Guard would have prevented that from happening in the first place. By using virtualization-based security, we encrypt the artifacts that Michael sucked out of memory, copied over the wire to another machine, and used that to resubmit them as though it were a TGT that it had acquired for its own purposes. ATA detected the event, but we now have both prevention and detection. Unfortunately, while ATA can monitor every existing Active Directory system out there, it doesn't matter what your functional level is. It doesn't matter what OS version it's running. As long as ATA is monitoring it, that detection would have occurred. However, Credential Guard is, I'm afraid to say, a fundamental re-envisaging of the way in which the OS boots and the way in which we handle certain secrets in memory. We could not push that down level. So you can only get CredGuard on Windows 10 and Windows Server 2016, but ATA is a bolt-on for your existing Active Directory systems, and it will at least give you alerts when these bad things do occur. You can see the additional sessions there. So next up, we're going to have Greg. Greg owns something referred to as software-defined networking. He owns the whole thing end-to-end, and he's going to talk to you about how we can use that for microsegmentation purposes, how we can stand up synthetic firewalls, and all that good stuff. So quick round of applause for Greg.
Thanks, Dean. All right, so earlier Dean said that the network is no longer the security boundary. Yet how many of you have turned off your firewalls? I don't see any hands, so none of you are brave enough to do that. We all have to rely on firewalls still, but we're finding that they're not effective. And the reason they're not effective is because they create a very small number of very large segments. You're not going to create a new VLAN for every single one of your applications you deploy. It just doesn't scale really well. So SDN is uniquely suited to be able to give you the agility to create hundreds or thousands of boundaries around every single application you deploy, around every tier within those applications, so that you can make it much harder so that, if somebody does get into that first hop, they get into your web server front end, they can't get to that next hop to get to those really valuable assets, and hopefully they wouldn't even need to test the credential guards that we have in place. So yesterday, in the Introducing Windows Server 2016 session, I showed how SDN can give you great agility in deploying your applications. We call it Azure-inspired agility. It lets you create a virtual network at the time you create your application, the time you create your VMs. You can configure subnets. You can configure load balancing. We include all of this in the box with Windows Server 2016. It also lets you very quickly create an application that is insecure. Somebody that, I did a somewhat contrived example of a phishing attack against the web server, where an attacker got some credentials. They got into the web server, and then once they got in, they used that web server as a launching point to move laterally from one web server to another, and then across to the file server, and then the Active Directory server. They used it, they attacked applications until they found a way to get through from one to the other. And then they just sit there and siphon off secrets. They siphon off the Active Directory credential store. They can continue to do this until they're detected and stopped.
Could we just pause there a second and give Greg a round of applause for his PowerPoint skills? Nice job, Greg.
Thank you.
Nice job.
Dean will be stealing this one from me, so he's just as guilty as everyone else. So, all right. So then I showed how that same agility you get in deploying your application lets you deploy a firewall onto your subnets very easily. We call this the distributed firewall within SDN. And we apply it to the subnet so that anything you put in that subnet gets that boundary applied to it. Those web servers have rules applied to them. So web server 1 can't even talk to web server 2. That security is enforced by the virtual switch. We can enforce it so that we only allow what's allowed in this case was port 80 to the web server, and then we deny all else by default. We also control what these machines can talk to. So we deny by default, but allow things like DNS to go through and a few other things needed for Active Directory and the file server, of course, the file shares that are needed to get to that second tier. And then the final thing we did yesterday was we inserted a virtual appliance. Because all of you that have firewalls out there, a lot of you love those firewalls. A lot of you have to use those firewalls. You may not love them, but you have to use them. And so when you bring SDN into the picture, you want to bring those firewalls into the virtual network. So you can use those same rich tools that all the firewall vendors have, but you need to do it in your virtual network. And so any virtual appliance that runs on Hyper-V, that's a security appliance or even not a security appliance, can run in a virtual network, and you can control the routing table of your virtual network to send traffic through that virtual appliance. All right, so let's jump into my demo environment. And we'll pick up where I left off yesterday with that deployment. So here we can see, let me shove everything over a bit, make myself some room here. All right, so here we can see my demo environment. You can see I've actually got my app deployed. This was the script that I ran yesterday to do that. Created a virtual network, added some machines to it, enabled some virtual IPs with the load balancer, and then I had my basic set of firewall rules. And of course, just to show that we have the actual web server up and running, I put a unique web page on each of my web servers so that as it load balances between them, you can see that each web server returns a different result. Well, that's great. I mean, we're doing a lot of kind of what you can do with your traditional firewall appliances. But where the real value in SDN comes in is in making it dynamic. Right? I mentioned that we put the rule on the subnet. That means that when I deploy a new web server, which I'm going to do in a minute, that web server that gets dropped into that subnet automatically gets the rules applied. I don't need to actually define any rules for that new web server. So if we go over here, go to the add web script that I'm about to run, and this isn't a very complicated script. Can any of you see any security policy in this script? Anyone? You can see I'm doing a few things. I'm getting a few objects up above. I create a few objects. I set some properties, such as which network I'm going to connect to. In this case, it's subnet number 1. I set an IP address, and then I configure load balancing and put it into the network controller. So let's actually run this script. And this should only take a second or two to run. Of course, in a demo, it always goes slower than you want it to go. And while that's running, we'll bring up web server number 3, and we'll actually see if those security boundaries got applied. We are still running. Things always take longer when you do them in a demo. I'll also bring up the browser to show that the app does actually add to that third web server. There we go. Well, it took 47 seconds, well under a minute to add that new machine. So now let's bring up the browser. Do a quick refresh. You can see now we don't just have blue and green, but we now have web server number 3, which is red. So now let's go to web server number 3. And if we didn't put any security policy on this, then you should be able to get to RDP into one of the other web servers. In this screen here, I have web1.contoso.local, which is one of my other web servers. Well, I'm not going to get to that because SDN automatically put on those firewall rules that basically say this VM can't talk to any of the other VMs, even on my same subnet. All right, that's great. But SDN is very dynamic. Let's say later on I realize, oh, I completely blocked remote desktop into these machines, but I actually do need to get into them. I just want to make sure I can't get into them from the outside world. Well, SDN makes that easy because that network security group that I created and put on top of Subnet 3 also gives me a single place that I can use to edit those rules and modify them over time. So I can either make them more secure, or in this case, slightly less secure. I'm going to open up RDP from the back-end subnets and block it so that I still can't get to it from across from the other web servers, and I can't even get into it from the outside. I'm also blocking that too. So let's go back to my script real quick. I'm going to do my revised security script, and the only thing I'm doing here is I'm getting my current network security group, which is called an access control list. Sorry about the scrolling there. It's called my rules. And I'm going to add an inbound rule that says deny on the same subnet. That's the 192.168.1.0/24 on the right side. So I'm still blocking the same subnet. And I'm only going to allow in from the virtual network. So this is within the virtual network. So it's not going to allow in from the internet. It's only going to allow in from the virtual network. If I ever add a subnet to the virtual network, that's going to get automatically allowed too, because this keyword, is very dynamic in that. So let's run this. Hopefully this will take less than, OK, that one went fast. Less than a second, I added this new rule. So now, you can still see that connecting across from the web server to web 1 is still blocked. So I am blocked within my boundary. But now if I go to my Contoso domain controller, which is on the back end, enter in web 1, I get the login prompt. This would succeed. And go to web 3, which is one I just added, and we'll see that it got the exact same rule applied. See, now we can get in from the back end. So that just goes to show you, it's very dynamic. It's automatic. It makes it very easy to maintain. Tomorrow, Thursday, I have a session on how to actually implement this, how to create these microsegments. I'll go into great detail. I'll actually show you how to add advanced threat analytics into your virtual network, use it as a virtual appliance. So thanks.
Excellent.
Thanks, Dean.
Thanks, Greg. OK. So we've talked about stuff that provides on-premises protections. We've talked about how shielded VMs implement isolations. We've talked about how we get devices that were previously not possible for virtualized machinery, such as a synthetic TPM. Our virtual TPM, we use those in shielded VMs. We've also shown you how with software-defined networking, Greg can stand up multiple instances of a technology that previously cost you $2,000 to $50,000 to buy for every single one. And he's provisioning them with just a few lines of PowerShell. Some very impressive stuff. One thing we haven't sort of touched on, though, is how does the cloud make all of this stuff easier? The cloud obviously brings many, many benefits. One of them is operationalizing certain technologies, such as monitoring virtual machines, protections, security, for example. Greg's obviously showing SDN on an on-premises way, but these capabilities also exist in Azure. But what about the ability to go in through and do security audit alerts, or to actually impact a virtual machine that's running because it doesn't have malware by installing malware on it simply by checking a few boxes? And I said anti-malware, or at least that's what I meant to say. I don't want to install malware. I want to install anti-malware. Got that backwards. So if you could welcome up to the stage Daniel. Daniel is going to walk you through Azure Security Center and give you an idea of the capabilities that we have in terms of making these things far simpler when working with virtual machines running in Azure. Welcome.
Thank you. OK, hi, everyone. I'm Daniel Alon. I'm leading the product management for Azure Security Center. And as Dean said earlier, I'm going to talk about what does it take to secure your environment in the cloud. Obviously, many of you, I assume, are moving some of their data centers or some of your applications to the cloud. And when you do that, you find out that some of the tools that are used to have on-premise, or maybe some of the control that you used to have on-premise, you no longer have that. And it's annoying, basically. And you want that control. You want to understand what is the security status of your environment in the cloud, and really, be sensitive to what's going on there. So Azure Security Center helps you with that. It gives you this visibility and control, this ability to understand very clearly what's going on from security perspective in your cloud environment, whether the security configuration is bad, whether it is good, and how you can remediate that. We also enable you to configure the security very easily. The security basically comes with the resources that you're using in the cloud. You can configure security from virtual machines, for virtual networks, for anything that runs in Azure. Basically, we will show you what kind of security control you can put, you can use for that. We are also working with a lot of partners, a lot of vendors in the marketplace. Microsoft doesn't produce all the security products or all the security solutions that you might want to use. And also, you probably want to use the same security solutions that you have on-prem. You probably want to use the same security solutions in the cloud. And therefore, we're working with all the vendors in the market today to provide this capability of simply deploying them for you in the cloud and integrating the security of these solutions with Security Center. And last, as all of us know, building security walls is not enough today. We need this detection layer that helps us understand if something bad is happening in our environment. Maybe the attacker got in, maybe he's doing something weird, maybe the VM is acting weird. So we need to use behavioral analysis and machine learning for that. And this is another layer that exists in Security Center. What comes with Security Center is also something that is called something that all of you know as OMS Security. It's almost like a twin to Azure Security Center. OMS Security includes a lot of functionality that exists in Security Center, but on top of that, it adds operationalization of all kind of security related tasks that you want to perform. For example, if you're missing patches, Security Center will tell you you're missing patches. OMS Security will also tell you that you're missing patches, but it also enables you to operationalize the installation of these patches. Also, you can correlate a lot of data in OMS Security, not just security data, but you can also correlate it to operational data, and you can use OMS Security for non-Azure environments, for example, on-prem environments or even AWS environments. OMS Security can run on those, or can give you security insights on those environments. So that's kind of completes the Security Center offering. So let's do a quick demo. And you can see here that there are multiple sessions on Azure Security Center and OMS Security. Michael, I need your password, sorry.
So Daniel is borrowing Michael's machine to do the demo, and it's gone to the lock screen. So Michael, as the owner of ATA, is going to type his password into a credential provider in a security session for somebody else so that they can use his account. I don't know what that means, but it means something.
I probably should have used the pass the ticket on Michael's machine. Okay, so this is the Azure portal, and you can see here that we have an Azure Security Center icon. When I open the Azure Security Center, we have two parts here. The upper part is the prevention, and the lower part is the detection. The upper part is a dashboard that gives you information about what's going on in your environment. You can drill into virtual machines, and you can see all the virtual machines that you have in your environment. As you can see here, we also have a virtual machine, which is a Windows Server 2016. So Azure Security Center already supports that. And for each of the virtual machines, you can see the different security issues that it might have. For example, system updates or endpoint protection, which is not installed. And I can go here and remediate the problem very easily. I can ask to install the anti-malware. And here you can see the partner play. Basically, we offer you to install Microsoft anti-malware or Deep Security from Trend Micro. And we're working with all the other vendors to add them to this list. It's all about freedom of choice. If you want to use Symantec, for example, you will be able to use Symantec. Probably, if you have Symantec in your on-prem environment, you probably want to use the same anti-malware on-prem, in the cloud as well. And I don't have too much time, but you can see here that basically what we do, we assess the security status of each and every resource that you have in Azure. Virtual machines, virtual networks, For example, you can see here that we show you the list of all the endpoints that are open to the internet. And for each one of them, we recommend you to put a network security group or next generation firewall from vendors like Check Point, Barracuda, and others. We also assess the status of SQL Azure and Azure Storage. And if you don't encrypt your Azure storage, we will recommend you to do that. All of that is being controlled by a security policy. Basically, you can tell us, you can configure the policy. So, for example, if in your environment or in your organization you don't care about this encryption, you can just turn off the recommendation. So it's very customized. And the detection part are really alerts that are about weird behaviors in your environment. And we have multiple level of alerts. We are issuing alerts based on network traffic analysis. So we can actually we see or we analyze the traffic that goes into your environment and outside of your environment. And using anomaly detection and supervised learning, we actually can detect all kind of suspicious behavior on that network. We also use virtual machine behavior analysis. We have an agent on your virtual machine that analyzes what's happening on the virtual machine, and it can alert if something fishy is happening. And last, we are also correlating the alerts into what we call incidents, which are basically attack stories. You can see here an attack story started a SQL injection, continued with RDP, which didn't succeed then, and RDP brute force succeeded. The machine started to behave in a weird way by SVC host process executed, which is not a real SVC host. And later on, it connected to a command control server. So what we also do is taking the alerts on your environment, correlating them into an attacks and giving you incidents, which helps you identify which items you should look first. That's it. Again,
great. Thank you very much, Daniel. Appreciate it.
Thank you.
Okay, so the demos we've done so far have definitely demonstrated the protection capability. Credential Guard, Device Guard, Remote Credential Guard, they both implement protections to stop these things at their very inception. They also embrace that isolation tenet. That's exactly what Credential Guard, Device Guard, they all use isolation technologies that are lent to us by this innovative capability that we refer to as virtualization-based security or virtual secure mode. Shielded VMs leverage the same thing. We then showed you some micro-segmentation capabilities, our ability to put into place software appliances that perform precisely the same functionality as what used to be 5-digit figures to buy them. And if you need another one when it's software-defined, just stand it up on a whim. It's that simple. We then showed you some of the remediation capabilities that Azure Security Center brings. When it finds that anti-malware software is not running, it installs anti-malware software for you. This is some clever stuff, and we've pretty much embraced every single one of those 4 tenets. But you remember earlier on, I started to deploy a shielded virtual machine. That will have finished by now. So what I'm going to do is I'm going to go ahead and simulate the final part of that attack vector against a shielded virtual machine. Now, the first thing I want to point out is there are 2 modes with shielded virtual machines. We have a notion of one that is extremely strong. It is shielded. It is protected from the prying eyes of administrators. We also have a mode referred to as encryption supported. You can see there in this policy, this type section, the security summary. One says shielded, the other says encryption supported, and the other says secure boot enabled. If you like, secure boot enabled has another phrase that we could have put there. None. But we don't want to say none, because it is leveraging secure boot, sort of, but it's not really using it for anything. Why are there 2 types of shielding then? Why do we have shielded and encryption supported? Shielded is when you actually need security. You are trying to protect that virtual machine from the prying eyes of SAN admins, any form of fabric administrator, Hyper-V admins specifically. They have no means of accessing it. They can't use PowerShell Direct. Integration components, such as the file copy integration component, they're all disabled. Console connections are not permitted. You can't attach a debugger to the process. You can't attach a debugger to the host. Oh, we should pause on that one. Who in the room knows how to use a debugger and attach it to a Hyper-V host? Show of hands. None. So that's a sophisticated attack, since we didn't get a single hand here that I saw. However, just because it's sophisticated, does it mean it's impossible? No, if you know developers, and obviously working as an engineer, I tend to know quite a few developers. If I let a Hyper-V host with a sensitive virtual machine anywhere near them, and they attach a debugger to it, you can just wash your hands of any secrets that existed there. You cannot do that with a Hyper-V host running shielded by virtual machines. The reason for that is we refer to it as a guarded host. A guarded host has to ask a host guardian service to decrypt the virtual TPM of any shielded virtual machine. That keying material will only be released to the Hyper-V host once it has undergone a very rigorous health attestation dance, where we measure all of the boot measurements that constituted its boot path. We look at some of the tooling on the box. We look at the drivers. We look at the kernel. We look to see if there are rootkits. We also look at the hypervisor-enforced code integrity policy to ensure that that machine is running a code integrity policy that leaves it secure. It is not susceptible to a threat from known malware because the malware couldn't run. So the code integrity policy is also measured. Finally, we look at the unique identifier of the TPM in that Hyper-V host. It's called an endorsement key, and we use that as the identifier to make sure that it is permitted to run shielded VMs, regardless of whether it meets the health policy. So you have to be identified first, then you have to pass a rigorous set of boot measurements so we know what you're running, then you have to pass, are you running a hypervisor-enforced code integrity policy that we permit? If all of those things are true, we will release the keying material in the form of a health certificate. But even then, it only sends back the keying material still encrypted to the virtual secure mode of the Hyper-V host. So even if you shimmed the network stack, even if you were Greg and you own the entire software-defined network infrastructure and you could sniff the packets off the wire, you're still going to see an encrypted lump of secrets that can only be decrypted inside the virtual secure mode of that Hyper-V host. Once all that has happened, the virtual machine can now power on because its VTPM can be decrypted and executed. The runtime occurs within virtual secure mode and is then projected into the resulting shielded virtual machine. At which point, what does the shielded virtual machine do? It goes through UEFI, secure measured boot, and exactly the same process occurs all over again in the virtual machine so that it can release the key to decrypt the BitLocker key. The security here is, to my mind, to my eye, and as we said earlier, I've been around for a long time, this is revolutionary. This is not an evolution of a virtual machine. This may be the banner by which we define virtual machinery as safe going forward. This may be the starting block, the new baseline. There are some additional sessions going on later this week, one where I'm presenting today with somebody that has already deployed a guarded fabric in Scotland. Who knows where Scotland is? Just checking. Who's Scottish? One. Okay, we've got one Scot in the room. But there is a guarded fabric already in existence. That session happens today. I'll show you what it's called a little bit later. But before I do all that, let me show you then what I can also do. Shielded virtual machines are all well and good, but what if I have thousands of VMs already running Windows Server or Server 2012 or maybe even Server 2016? I'm not going to want to redeploy them as shielded. That's monumentally challenging from an operational standpoint. I can convert them. Look here. Wrong mouse. This one that says Secure Boot Enabled. That's the guy that we attacked earlier. Look at the button that highlighted on the button bar up top in VMM. If I click on the shield icon in the virtual machine management console, this is System Center VMM, it's fully enlightened to shielding. VMM can fully deploy a guarded host from bare metal. So it can deploy Hyper-V and configure it with the hypervisor-enforced code integrity policy. VMM can deploy the whole thing from the ground up. It can also control the virtual machines. By merely clicking on Shield for a machine that is not shielded, the only thing I actually have to do is select the right shielding data. I would click on that shielding data, click on OK, at which point the virtual machine must be powered off. We grab hold of its disk. We start injecting the synthetic devices into the virtual machine in its powered-off state. We then go through and we generate a new BitLocker full-volume encryption key. We wrap all of this technology into one button, Shield. We then encrypt the disk for you, and once the operation is done, the machine will say shielded, or it will say encryption supported. So let's finish the definition of those two. So shielded prevents anything from happening. Encryption supported is most useful for compliance scenarios. It's a very, very useful way. If you need to check a box that says data is encrypted at rest, and it's running on a workload, that wants to be a VM, then use an encryption-supported device. Encryption-supported VMs still support console connections. They still support integration components. They still support PowerShell Direct. But their disks are still encrypted. Live migration traffic is also encrypted. They still use virtual TPMs. The virtual TPM is unique to every single shielded VM. It is not shared. It is not bound to the TPM in the host. It is an entirely synthesized VM that will only be decrypted, again, if the host passes those rigorous measurements that I mentioned earlier on. So you can see here, I can not only deploy shielded VMs that are born secure, I can convert existing ones. So if I go into this PC and I try and attack the disk by going into the SAN, going into the virtual disks, going into VHDs, ADDC2 we know is shielded, I'll double-click it. The drive is BitLocker protected, so what does that mean? What did we actually do with it? If I come back up to the top, you've got a good indication here. It's got a padlock on it, indicating that this is encrypted. Let's try and double-click on it. And I get a more useful error at the top right, saying that there are no supported protectors on this drive, albeit in an unbelievably small font. What it's basically telling me there is BitLocker uses a symmetric full-volume encryption key. We call it the FVEC for short. A key protector is the thing that encrypts that key. We are here looking for a key protector to decrypt the full-volume encryption key of that disk. Well, there's only one place that that full-volume encryption key lives, and it's in that VM, encrypted by a key that is sealed to that virtual machine's synthetic trusted platform module. The only way you're getting that key out, short of finding a way of attacking BitLocker itself, is to make that machine boot properly, with the blessed boot path and the blessed code, at which point it's now legitimately defending itself. It's running. We can't attack it while it's off. We can't attack it while it's on. What about the universal security bypass prompt, aka the command prompt? Can I attack it that way? No. Bit of a silly thing to show here, but some people sometimes believe that the protections exist in the GUI, in the interaction phase. No, the drive itself is entirely protected. All right, so we've completed all of the demos there. So let's just get back and finish off with our closing slide then. This is everything that we can think of, everything that we've done as part of the Server 2016 wave. Everything's possibly a bit bold. I've just thought of 2 or 3 other things. This is a good chunk of the things that we've done for the Server 2016 wave, both on-prem and in Windows 10 client, as well as in the cloud. Now, if we take a look here, compliance is obviously significant these days. Now, the reason I point this out now is we have spent a huge amount of time trying to help you guys with compliance problems. So what we've done is we went out to an independent third party and we had them assess various implementations of our various technologies and then map them to specific compliance requirements. What this means is, let's say, for example, you needed to comply with the payment card industry's DSS requirement, 3.2. The only thing that you have to do to comply with PCI DSS 3.2 is run the workload in a shielded VM. Job done. And we have those compliance assessments for all of the technologies that are listed there. You can go and download those now. Obviously, I didn't put the URIs up here because it would just be impossible for you to read them. So once you get a copy of this slide deck, you can click on those links. I promise there's no malware at the back end. Honest. Trust me. These are just links that show you exactly what compliance bar you can attain merely by implementing these workloads. All right, so here are the related sessions. Going out in no particular order here, we've got the Protect Your Infrastructure and Applications with Server 2016 Security. That's where we dive in and do more demos on CredGuard, Remote CredGuard, Device Guard. We've got Secure Privileged Access. That's where we look at things like the Privileged Access Account Management, capabilities that are built into WinServer 2016, such as time-bound groups and all that good stuff. A deep dive into shielded VMs, that's with myself and Lars. Lars is a program manager from the Hyper-V team. He owns all of the technology in Hyper-V that constitutes the shielded VM. And then he and I work together, and with the 2 of us added, you've got the entire scenario. And then last but not least, you've got a session this afternoon where we will actually show you, through a video and various other ways, the deployment of a production-guarded fabric that is running live today in Scotland. With that, please do evaluate the sessions. It lets us know whether we did well. Thank you very much for attending. Much appreciated.